All right, tomorrow is the test. These problems here don't have any graphs. I would say most of the problems tomorrow will have graphs. Maybe one or two will not have graphs. But like, natural log e to the x. So do we have questions on any of these? Even though I did a video on it.
You did? I thought you said you didn't.
Huh?
I thought you said you didn't do a video for this one.
I didn't? Well, I've got written solutions though.
Yeah.
Also, then you might have questions still.
Yeah, that's not.
Okay, I'm going to tell you right now. Number 7, there was a problem just like it on the homework. But who knows if you did it or not, and who knows if you even did number 7. But number 7 tomorrow, that's worth like 10 to 12 points right there.
Oh, wait, what? Why?
Because look, you got a part A, B, C. Okay, let's just make it 10 points then. So we are going to do number 7 from the review worksheet. Number 7. Now the only thing I'm going to do is I'm just going to change the equation. Like on your homework, wasn't it like y equal x squared, I think?
Sure.
I forget what it was, and then now it's y equal x to the 4. What will it be tomorrow or on Thursday, and y equal 9? Okay, y equal x, well anyway, it's going to be this U-shaped thingy, that's what it's going to be. And then y equal 9 is this horizontal line. So if you take this region and you revolve it about the y-axis, can you see that you're going to get a bowl? Okay, so what you have to do is you have to find the volume of this bowl. Now, can you see that the region on the left, you really don't even need the region on the left, yeah? There's a region right here. So we just take it away. Like if you just take this half region right there, and you revolve it about the y-axis, you will get the bowl. That's what you're going to have to do. So how do you find the volume of this bowl? Well, you make a rectangle. How come I made the rectangle horizontal? Because Mr. Park, the equation says y equal. That's a hint to it vertically. Well, usually. Anyway, doesn't it say use discs to find the volume of the bowl? Anyway, think about it. If you drew the rectangle vertically, isn't that rectangle parallel to the axis of rotation? So when you revolve it around, you're going to get shells, which we didn't learn.
Wait, what would it look like?
So like here, you have it, oh my God, here's the y. It doesn't have to be the y. But if you have it like this, when you revolve it around, you're going to get a shell. It's basically a cylinder, but it has a thickness to it. But we didn't learn that. We're AB. So the only way you can get a disc out of this is you got to draw the rectangle horizontally. That way, look. You have a disc. We know how to do. There's only 2 things you got to know how to do. Discs and washers. That's all you got to know. We don't do shells. Okay, so that means I have to change the equation to x equals. So if y equals x to the 4th, then x equals y to the 1/4, or the 4th root of y, whatever you want to write, it doesn't matter. Okay, now what's the formula for a disk? Pi times the radius squared dy. And this is the radius, and how do I find that? Right minus left. Y to the 1/4 minus 0. Hey, we've got to go over the quiz. We'll do this first, and then we'll do the quiz. Almost forgot the quiz. And then you add up all of these disks from 0 to 9, because isn't the y coordinate down here 0? The y coordinate up there is 9, so 0 to 9. Okay, now can I compute this integral? Yes, you can. Throw the pi on the outside because it's a constant. And what do you do with the exponents? You multiply, so you get y to the half dy. That's an easy integral. Make the power 1 bigger, so that's y to the 3/2 with a 2/3 in the front, but we already have the pi there. From 0 to 9, factor out the constants if you want to. 2 pi over 3 times, what is 9 to the 3/2 power? Just square root it first, and then cube it. 27 minus 0, and then simplify this. 3 goes into 27 9 times, you get 18 pi. That is the volume of this bowl. Hey, you don't have to put units on the AP exam. If they don't ask for units, don't give it. Because if you volunteer it and it's wrong, you're going to get points taken off. The only problem where you have to put limits is the related rates one, which is part C. Okay, so everybody see how to do this? You have to make the rectangle horizontal. You have to. Okay, part B. It says, if the height of the water if H is the height of the water in the bowl. So let's say, here's the bowl, and the water goes up to here. So, oh, I thought you were just excited about this problem. Okay, here's the height of the water. Can I figure out what it says? Look, if H is the height of the water in the bowl, write off the volume of the water in the bowl as a function of H. So, that's why you did part A first, so you can use that to do part B. So, again, look, you have the disk, pi times the radius squared dy. Nothing changes, except if I want to find just the volume of the water in the bowl up to here, instead of integrating from 0 to 9, you integrate from 0 to H. Exactly. 0 to H. You guys understand that? Because H represents the height of the water. Because the height of the water might not be all the way to the top, right? If it's all the way to the top, then that's the volume. But you're going to go from 0 to H. So you do the same thing. In fact, why reinvent the wheel? Just do the same integral you did over here, except just go 0 to H. So just do this. Why reinvent the wheel? Y to the 3/2 from 0 to H instead of 0 to 9. All right, plug in the top number. What do you got? Really? H to the 3/2, now plug in 0, you get 0. This represents the volume of the water if you know the height. So for example, if the height of the water is only 1, what would the volume be? Plug in 1 there, what do you get? 2 pi over 3. What if the height is 4? What's the volume of the water in the tank? Plug in 4. What is 4 to the 3/2 power? Square root and then cube it. 8 times 2 pi over 3, 16 pi over 3. So this formula tells you what the volume of the water in the bowl is if you know the height. All right, now part C. This is the big points right here. So if this problem is worth 10 points, I'm guessing this one would be 3. Make it 4. No, that's right. This problem is going to be worth more than 10 points. I think it's going to be 4, 3, and 5. That's what I think it's going to be. 5. Because this is the meat right here. Now, if water is being pumped into the bowl at a rate of 5 cubic units per minute, how fast will the water level be rising right when the height gets to 4? This is a related rates problem. Now, you guys remember how to do related rates?
Sure.
Probably not, because it was a long time ago. But remember the 3 steps for related rates. 1, write the equation. See, without this equation, it's very difficult to get the other 5 points already. Second step, take the derivative with respect to time. Remember the h dot and the v dot? Does that even sound familiar? Anyway, v dot means the same thing as dv dt. Now, I don't care which way you write it, v dot, they both mean the same thing. So here's your equation. Take the derivative with respect to time. So what's the derivative of v? V dot, or dv dt. It doesn't matter which way you write it, they mean the same thing. Here's a constant, we throw it on the side, like an unwanted pen. And how do you take the derivative of h to the 3/2? Is it simply 3/2 h to the 1/2? No, because then you're gonna times it by the derivative of box, right? What's the derivative of box to the 3/2? 3/2 box to the 1/2 times the derivative of box. What is the derivative of h? H dot. Anyway, if you don't have the h dot here, that's what we're trying to find. How fast is the water level rising? H is the water level. So by computing h dot, that's what we want to find. So if I want to compute h dot, I have to plug in numbers for v dot and h. And do we know these things?
Yeah.
They're all given in the problem. So it says water is being into the bowl at the rate of 5 cubic units per minute. So where do I plug in the 5?
V dot.
That's V dot. What if I said water was being cycled out? Then it would be negative 5, yeah? Because the volume is getting smaller. Now what do I plug in for H? It says, how fast is the water level rising when H equals 4? Yeah, obviously you plug in 4. And then now can you do computations?
Hopefully.
Well, let's see. So what do we have now? 5 equals 2 pi over 3 times 3 halves times 4 to the half times H dot. Well, 3 cancels 3, 2 cancels 2, and what is 4 to the 1 half? 2, so this is 2. So you got H is equal to 5 over 2 pi. And, oh, this is H dot. And then this is the only problem where you have to give units now, related rate. So remember, H dot means dH dt, height over time. So in this problem, if you have to measure, somebody has asked you, measure the height, what units would you give? What is the height of the water? Units. And then what is the time? Is it minutes, seconds, or is it hours? Where is it?
5 cubic units per.
Oh, yeah, per minute. So it's units per minute. Units per minute. Box that, that's the answer.
Perfect.
Can you repeat this problem? If I just change this to like x to the 6, x to the 8, x to the 9?
Hopefully.
Hopefully. So this problem is on the wall, obviously. All of these problems are on there. Okay, let me pass out the quiz. We need to go over the quiz. All right. Supper. Suzuki. Hello. Right here. Chihuahua. Good work there. Henry. Lee, right here. Lee here. Andrew right here. Hobbs here. Cole here.
Oh shit, that's bad.
Yeah, don't multiply it out. Because you multiplied it out wrong.
Oh, so sad.
Read the exam.
Holy
Like that.
20.
Oh, I think I should say 3 times. Is there like a moment when you would have gotten an A if you had just done this for all of the problems?
Okay, we're gonna go over every single problem. These are basic problems now.
Is that your worst quiz? My
Okay.
worst is 22.
Right back. Oh, yeah.
Okay, number 1. I gave you the graph. The graph is given. Tomorrow you're probably gonna have to draw your own here. This is y equal root x. This is y equal 2 over here. And x, anyway, so intersection point. Now if you wanna set them equal to each other, like this is y equal 2, you can, but come on, just guess and check. 4, 2. It's probably easier. Come on, think about it. When it's square root, what numbers am I gonna use? Either 1, 4, 9, 16, or 25, right? Something that can be square rooted. If I give you a cube root, probably gonna be like 1, 8, 27, or 64, and so forth. Okay, write an integral that represents the volume of the solid if cross sections perpendicular to the x-axis are squares. So perpendicular to, so those of you having trouble, you have to draw in the rectangle. The rectangle is the key to the whole thing. So for part A, the slice is a square. The base of the square is lying right on that rectangle. How do you find the length of a rectangle if it's vertical? Top minus bottom. If it's horizontal, you go right minus left. So top minus bottom. Now if you know the side of a square, how do you figure out its area? No, you square it. You square it, but it has a thickness to it. And then you add up all of these squared slices from no, that was premature. I told you, you gotta wait till the dinging stops. I didn't. My voice is going. Okay, here. Ring. Okay, that's too late. Ring. Okay, thank you. And just leave it. Just leave it. Don't simplify, because if you simplify, I didn't take off on the quiz, but on the test, if it just says to write the integral, just write it. That's it. That's good. And of course, tomorrow you can see all the shapes: square, equilateral triangle, semicircle, isosceles right triangle. Okay, next one. Cross sections perpendicular to x-axis are equilateral triangles. The base is lying right on that thing there. So how do you find the length of the rectangle? Top minus bottom. What's the formula for area of an equilateral triangle? √3/4 times the side squared. But there's a thickness, dx. Add them up from 0 to 4. Okay, part C. Cross sections perpendicular to the x-axis are semicircles. Okay, a lot of you got -2. Semicircle means half a circle. Okay, so what's the formula for area of a semicircle? Well, half a circle. So 1/2 pi times the radius squared. Okay, but the diameter of the semicircle is lying on that rectangle there. So if the diameter is top minus bottom, what will the radius be? Won't it be half of that? Right? Isn't the radius half the diameter? Yes. And then there's a thickness to it, dx. Add them up from 0 to 4. And leave it. Leave it. Don't multiply out unless I ask you to compute it. Part D. Cross sections perpendicular to the y-axis. No, I underlined it now. On the AP exam, they're not going to underline it. You got to read that. So perpendicular to the y-axis. Now you got to draw the rectangle like that. Perpendicular to the y-axis. Okay? And then whenever you draw a horizontal rectangle, you have to write the equation as x equals. So what do? Square both sides. X equals y squared. And of course the y-axis is x equals 0, right? So what are we doing here? Isosceles right triangle where the hypotenuse. So here's the hypotenuse, which is lying right on that rectangle there. How do you find the length of the rectangle? Right minus left. Y squared minus 0. Don't assume it's always going to be 0, that's why. So y squared minus 0. Now, if you know the hypotenuse, can you figure out the area of this triangle? Yeah, because in a 45, 45, 90, if you know the hypotenuse, how do you get the side? Divided by √2. And how do you find the area of this triangle? 1/2 base times height? Yeah. Or you want to just go half a square? No. Well, I mean, whatever you want to do. 1/2 base times height then. But it has a thickness, dy. How come dy? Because I drew the rectangle horizontally. And then you add it all up from 0 to 2. The y coordinate here to the y coordinate there. 0 to 2. Don't worry about simplifying these. Just leave it. Okay? Now, number 2. Compute the integral for problem 1a. Now you got to actually compute this. So the only way you can do this one, but you can see these are easy integrals. Tomorrow you know, right? Gonna have u substitution. Gonna have what? Integration by parts and tabular, which is integration by. Okay, make sure you guys multiply it out correctly. Like, come on, man. That's algebra 1. Come on, if you have to do this, go a minus b squared. Oh, that's a squared minus 2ab plus b squared. Right? Algebra 1. Okay, antiderivative. 4x minus, this is like x to the half. So you make the power 1 bigger. Put the 2/3 in the front, so that's going to be 8/3 plus 1/2 x squared. From 0 to 4, plug in the top number. 16 minus 64/3 plus 8 minus left is to make a least common denominator, so that's 3. So what do we got? 48 minus 64 plus 24. So that is 72 minus 64, 8/3. Box that, that's the answer. Okay, second page. Yeah, these are kind of tame for what you're gonna, compared to what you're gonna see tomorrow. Well, like that, right? I want you to be able to do integrals. Okay, number 3. So here's a, okay, so this is y equals sine 2x, y equals 0. Find the volume when you revolve it about the x-axis. So draw the rectangle this way, because it's got to be touching the axis of rotation to get a disk, right? So draw the disk. Pi times the radius squared dx. Now, the radius is the length of the rectangle. How do you find that? Top minus bottom. Sine 2x minus 0, and then add it up from 0 to, oh, now you got to know where that is. I think you guys got that one. What is it? Pi over 2. Because when is the first time sine will be equal to 0 after 0? At pi, right? So you got to ask yourself, when is this equal to pi? Pi over 2, right? Okay, now next thing, now you got to compute this. So pi. What's the only way in the whole world to integrate sine squared? You got to replace it with the identity 1/2 minus 1/2 cosine 4x. How come it's 4x? Well, whatever that is, it's got to be double that, right? And then the antiderivative is easy. 1/2 x minus 1/8 sine 4x from 0 to pi over 2. And then plug in the top number. What is that going to be? Pi over 4 minus 0 minus 0 minus 0. Come on. I think we can simplify that one. And then number 4. I think I made this one a little too similar to the first problem. So this is y equal cube root of x, y equal 2. Revolve it about the line y equal 2. So here's y equal 2. So draw the rectangle this way, so you get a disk. See, if you guys are having a hard time, my first guess is you're not drawing the rectangle. The rectangle is the key. So disk, pi times the radius squared dx. How do I find the radius of this disk? Top minus bottom. 2 minus the cube root of x, or if you want to put x to the 1/3 to make it easier, whatever. Add them up from 0 to, now where is this? 8 comma 2, right? Cube root of 8 is 2, that's why. So 0 to 8. Do we have to actually compute this one? Yes. So pi, multiply it out. 4 minus 4x to the 3rd plus x to the 2/3. Easy. 4x minus, make the power 1 bigger, put the reciprocal 3/4 in the front, so that's just 3. Make the power 1 bigger, put the reciprocal in the front, 0 to 8. Okay, plug in the top number. Let's see, 32 minus cube rooted at 16, that's 48, plus 32, so 96/5. And if you plug in 0, you get zeros. All you have to do is make a least common denominator. I think I'd rather just simplify that to -16 already. So -80 plus 96, that comes out to 16 pi over 5. Box that, that's the answer. Yeah, there's hardly any trigonometry on this one. Don't worry, you'll get your share tomorrow or the next, whenever it is. D. Okay, revolve it about the y-axis. So that's why you have to make the rectangle horizontal. Because if you made it vertical, you would have shells, but we never learned shells. Okay, that's why you need to draw the rectangle in so you can see what you got. Which means I've got to change the equation to x equals. So x equals y cubed Yep. Okay, so this pi times the radius squared dy. The radius is the length of the rectangle, so right minus left. Y cubed minus 0, add them up from 0 to 2, because you're doing it with respect to y, so y to y. Okay, so this simplifies to y to the 6th. That's an easy integral. Y to the 7th with a 1/7 in the front from 0 to 2. So you got pi over 7 times 128 minus 0. Final answer, 128 pi over 7. Yeah. All right. Okay, let's just do one more problem. Okay, wait, let me think of, oh, question.
For the test tomorrow, are we gonna have to draw all of our graphs?
No, maybe one or two only. I'll give you the graph for almost all of them.
So should we study like how to draw trig graphs,
Well,
or is it gonna be graphs we know how to draw?
yeah, like sine, cosine, you know, the basic ones. E to the x, natural log x. Because look, the homework had a lot of e to the x, natural log x, yeah? Okay, let me think of a good one. Okay, wait, I'm formulating this in my head here. Okay, take this region, I'll probably give you this picture. Revolve it about the line y equal 2. Find the volume of the solid. No, I changed my mind. Revolve it about the line y equals 3. Yeah. That's what we're talking about there.
Big radius.
Okay, look. Now remember, whatever the axis of rotation is, the rectangle has to be perpendicular to it. So you gotta draw it this way. Now if this rectangle goes around that line, what are you gonna get? Is it a disc or a washer? There's only two choices.
Washer.
It's a washer, so. Okay, so what's the formula for the washer? Pi big R squared minus small r squared dx. That should be engraved in your brain already. Now, how do you find the big radius? Center to the outer edge. Top minus bottom.
3 minus whatever the
3 minus secant x. Inner radius goes from the center to the inner edge, right here, small r. How do you find that distance? Top minus bottom.
1, 1.
3 minus 2. Because this is 2, yeah, y equal 2. And then add up all of these things from. Okay, so this is where you. See, I'll give you the graph, but you better be able to figure out where the points of intersection are. So what is this and this?
Pi over 3 and 9.
Oh, come on. If you're gonna do this without a calculator, this one it's either pi over 6, pi over 4, or pi over 3. That's it. How come it can't be pi over 2?
Too big.
Yeah, that's because secant of pi over 2 is undefined. There's a vertical asymptote there. So it can only be one of those three. So you want to guess and check? Or it's pi over 3. How come? Because what is the secant of pi over 3? 2. And that's what the y coordinate there is, 2. Okay, which means this is negative pi over 3 by symmetry. So you want to go negative pi over 3 to pi over 3?
No.
Or you want to go 0 to pi over 3 and times it by 2? Yeah, that's because you guys already have a hard enough time plugging in trig values. Isn't it better if one of them is 0?
Yeah.
But you can only do this if you have the symmetry now. Okay, now here's the second problem. Now we gotta compute this integral. Okay, what do I need to do? The only thing you can do is multiply it out. So 2, integral 0 to pi over 3. And then let's throw the pi out there as well. Start multiplying out. What do we got? 9 minus 6 secant x plus secant squared. Oh, this is not as difficult as I thought it was going to be. Minus 1. And the only thing you can really simplify is 9 minus 1 is 8, right? You don't even have to do that. So 8 minus 6 secant x. Oh, this is, oh. I wanted something better than this, but too bad.
It's hard.
Because these are, you don't have to do anything. These are all on the list. Come on. 8x minus 6 natural log, absolute value, secant x plus tangent x. Plus, there you go. See, it's all on the list. That's a problem, Mr. Park. Okay, plug in the top number. 8 pi over 3 minus 6 natural log 2 plus root 3 plus root 3 minus, plug in 0 minus 6 natural log 1 plus 0 plus tangent 0. 0. Okay, so you do that, you're going to get everything except 1 point. What is natural log 1? 0. So all of this is just 0. So this is your answer right here. I guess we should write it nicer, yeah? 2 pi times 8 pi over 3, because you can't really add any of these together. There, full credit, right there. Darn it, I don't know why in my mind I thought I could get something where you could do tabular. But don't worry, you had plenty practice on tabular on that one, right?
Sure. What's tabular? Not yet.
What's tabular?
Oh, the thing.
Are you kidding me? That's like here. Okay, let's review tabular.
Wait, can we?
Hey, I want, you know what would be the best? Everybody gets 100. It would be so easy to correct that. Go. Correct. But every time there's a mistake, then you gotta go in and then you gotta find the mistakes and things. Okay, like this, tabular.
No. What is that? X squared.
Okay, so suppose whatever you do, you get something that looks like this, okay?
Okay.
So how would you do this integral?
Tabular.
Tabular. How do you know you can do tabular? One of them has to be a polynomial so that you can take the derivative down to 0. The other one has to be able to be repeatedly integrated 3 times. Can you?
Yeah.
What's the antiderivative of this? Good. Negative 1/3 now. We're taking antiderivative, not derivative, yeah? So then,
1
1,
9.
Oh.
and then,
Negative 1/7.
and then you go tic-tac-toe, plus, minus, plus. So you're gonna get this times positive 1. Negative 1/3 x squared e to the negative 3x minus 2 9 x e to the negative 3x minus 2 27 e to the negative 3x from 0 to natural log 2. Okay, we still got points to get over here. How come it feels so warm?
I don't know.
Alright, plug in the top number. Okay, let's see how good you guys are. Plug in the top number. Negative 1/3 natural log 2 squared. Okay, now you got e to the negative 3 natural. This, even students in BCA, you have problems like this. They came in for problems. I gave them this. Even they committed.
1/8.
That's 1/8. You guys see why? Because look, when you have a logarithm, what can you do with the number in the front?
Put them on the top.
Put it up as the power, And e to the natural log banana is banana. That's 1e. And then minus 2 nines, natural log 2, 1e, minus 2 27s, 1e,
Gone.
minus, oh, be careful now.
Not gone.
Now, can you assume that if you plug in 0, you're just going to get zeros?
No.
No, that would be a bad assumption. Okay, you plug 0 in here, you get 0. You plug 0 in here, you get 0. You plug in 0 here, e to the 0 is 1, so you get negative 2 over 27. And then I'm assuming you guys can simplify this, right?
That doesn't even come up nice.
Yeah, this is not nice. I just want to make sure we review tabular, because I'm pretty sure you can do it at least 2 times tomorrow. Question.
If this x cubed, can you still say tic-tac-toe?
Tic-tac-toe. Tic-tac-toe. Yeah, that's it. I got it right there.
That's because there's 3 lines.
All right.
Tic-tac-toe.
Okay, we got, when is this class in? 12. You guys got 13 minutes then.
Well, yes,
Maybe some of you gotta actually do this thing now.
Oh, yeah.
This worksheet.
Yeah.
You guys are admitting that.
Yes.
Because all the letters of recommendation are in already.
Yeah.
No worries, mate. Okay, let me turn this on. Okay, Lee and Hyler, this is for you.